As Jennifer mentioned, the title of this talk today is Climate Change Caused by Humans? And I hope you know that it is in a series, that there are more to come and you can join us. First, I do want to ask you to answer these couple of questions. So Jennifer will help me put up the link for you to participate on this poll. And the first one is, I'm asking what do you think of climate change or global warming? So go ahead and answer what you think of global warming. I would like to know, is it a political propaganda? Or is it something the media jumps to cover? Is it true and it only affects a certain part of the world? Or is it a global phenomenon that has many impacts? Okay, let's see what you think. Are you able to input your answer? I'm not seeing anybody inputting yet. I'm going to give you a couple more seconds to see if you can input. Is it working, Jennifer, for you? Are you able to do that?
Yes, I put it in the chat.
Oh, okay.
Can everyone see the link in the chat?
I wonder if the rest can see that. Oh, there, we have somebody responded. How about now?
Okay.
Can you see the chat? Okay, thank you for telling us. Okay, we have some responses, a few. Okay, it is true. If you have a phone, you can text as well. And the number is on top of the screen. That is strange. Okay, I see more of you responding, okay.
And I will keep typing it in for you, those that are joining late. Thank you, Stacy.
Okay, all right. Thank you, everyone. Well, okay, well, I have some of you responded, even though it is not all of you. Well, I have a next poll for you and see if this one works. So Jennifer, you can help me put that in the chat box.
Okay.
I'm curious if you've ever considered, based on the distance from the sun, what should be the average temperature on Earth? So here are your 4 options: 18 degrees centigrade, 0 degrees centigrade, minus 18 degrees centigrade, or just be honest, I don't know. Thank you, thank you. Thank you. Okay, all right, so we have different answers. Okay, all right. Great, great, this is working. Okay, thank you. Well, I want to bring us back. Thank you for your participation. I want to invite you to space travel with me to a galaxy far, far away. Actually, just go into the solar system. Did you know that based on the distance of the Earth from the sun, the average temperature on Earth really should be minus 18 degrees centigrade? Yes, that's very cold. However, we all notice that that is not the case because we live pretty comfortably, especially in Southern California, right? So the Earth's current average temperature, remember, this is the global average temperature, not just in California, is 15 degrees centigrade, which is comfortably Maybe a little bit cold for us Southern Californians, 59 degrees Fahrenheit. So you might ask, why is there a discrepancy? And how is that happening? We need to go back to the sun. Did you know that the Earth, major source of energy, comes from the sun through 3 processes of reflection, absorption, and emission? And through all that, there is something called the greenhouse effect, in which our atmospheric gases, such as carbon dioxide, water vapor, can trap a major portion of the heat radiating from the Earth, and as a result, keeping us somewhat warm. It is a natural and necessary process. That is why we don't live in ice age. We are not at minus 18 degrees, what is supposed to be. I personally think that this is our Creator God's infinite wisdom and deep love for us, that He wants us to be protected and live in flourishing ways. And therefore, the greenhouse effect is a natural process that He designed. So, what is the greenhouse effect? It is really a natural process, as I mentioned, by which atmospheric gases, such as carbon dioxide, water vapor, so on and so forth, can trap a major portion. For those of you who like numbers, it's 80%. That is the value we need to bear in mind of not just any energy, but infrared radiation. You might know that the sun does offer us ultraviolet radiation and visible light as well. And infrared is the one that we want to be thinking of right now. If you still have a hard time visualizing or conceptualizing what greenhouse effect is, I want to ask you to think about a parked car with all windows up on a hot day in a parking lot, which we have a lot of those days in Southern California, don't we? Now, hopefully, we don't leave any kids nor pets in that parked car, because that would be very inhumane. That is the greenhouse effect. And therefore, this effect can warm the atmosphere. Some of the gases that are considered greenhouse gases include water vapor, carbon dioxide, methane from agriculture, nitrous oxide, ozone, and chlorofluorocarbon. The latter 3 are all pollutants. Now, even though greenhouse effect is natural and it's necessary, it is a good thing, but too much of a good thing may not be good, as we know in other parts of life. That brings me to the enhanced greenhouse effect. If greenhouse effect is natural and necessary, and that 80% is what we are hoping for, then when we have more than 80% of the heat that's radiated by the Earth being trapped and returned, then we have something known as the enhanced greenhouse effect. And that is the main reason for global warming, in which the increase of average global temperature is a result of this effect. Now, I want to emphasize on average and global, not just about LA or California, not just 1 year, but it's really the whole Earth taken into consideration. So I hope you will bear that in mind as we continue. And I hope you understand the difference between greenhouse effect and enhanced greenhouse effect, and more so what enhanced greenhouse effect will lead to. Now, some of you might already think, well, Earth's climate does change. You're right. There are natural phenomena, such as the Earth's orbit and tilt. Those of us who've been to the beach, of course, would notice high tide and low tide. And there's also natural changes in atmospheric gases, such as carbon dioxide. However, there are human-caused influences in these following processes: industry, transportation, mining, and agriculture that will lead to a large influx of carbon dioxide that is not natural. Let's take a look at carbon dioxide emission by end use. This next pie chart shows us how power heating stations, industry, deforestation, transportation, agriculture, residential and commercial buildings, as well as waste and wastewater, all contribute to the global carbon emission. Even though you and I might not be miners, we might not be in agriculture, which you should be thankful, because I have a black thumb. If I grow anything, everybody will starve. Even though I don't sew garments or make products, we are all consumers, users, and beneficiaries of these processes. And as a result, we are all in this together, and no one's left behind. Let's take a look at carbon dioxide concentration over time, especially. Shown here is a graph that shows us how much carbon dioxide concentration. And I want to first walk you through how to interpret this. The time year is on the x-axis, as you can see, from about 1960, a little bit before 1960, actually 1958, to more current. And on the y-axis, we have carbon dioxide concentration in parts per million. So you would read 320 over a million if it's a fraction. Now take a look. The red zigzag line indicates the change in carbon dioxide concentration over time. And the black line here actually is a trend line from the beginning to the end of this study. I don't think you have to be a statistician nor a scientist to notice a certain trend in this graph. If you feel comfortable, you can unmute or you could put it in the chat. What kind of trend, I wonder, do you notice? What kind of trend do you notice on this graph? Again, you're welcome to unmute if you feel comfortable, or you can respond in the chat as well. Thank you. It's an upward trend. It's steadily rising. We can safely say based on this graph that the carbon dioxide concentration increases over time. And of course, you know, in the inner box, you see that there's a cycle. Every year, every calendar year from January to December, there's increase and also decrease. As I mentioned, it's natural. However, the overall trend year after year, we're seeing an increase, and that is concerning. Now, I wonder, among some of you, you're wondering, well, okay, 50 years, half a century, that's long, but that's not very long. What about 100 years ago? What about 200 years ago? What about 2,000 years ago? Well, okay, let's pull back the timeline. Scientists thought of that too. And some went to the coldest part on Earth, to the ice caves, to look at ice core samples in which these carbon dioxide gas would be frozen over a long period of time. And scientists measure how much carbon dioxide existed in a long time ago. So here are the results. Again, time is on the x-axis and carbon dioxide concentration in parts per million on the y-axis. The Mauna Loa data that we just saw are the red dots that's closer to 2000, year 2000. And then there's one set of ice core data from the South Pole in the green triangles. And then there's another set of ice core data from the South Pole as well in the blue squares. Now, if I have a ruler, I can pretty much draw a straight line through these blue squares, can't I? And we can read that is a bit below 300 and in between 250 and 300, well, roughly about 280. And then something happened around the year 1800. There is seemingly an increase and a steady increase. And there doesn't seem to be any signs of slowing down or the trend line decreasing. So I wonder, what are some of your thoughts? Why do you think there's an increase right around 1800?
Feel free to ask questions and unmute or type in the chat. Dustin is asking, what is the scale on the annual y-axis?
Do you mean the parts per million? Okay, I'm gonna come
Louise,
back.
on the annual cyclic one from the previous slide is what I was asking.
Okay, I believe it was also a ppm. But I'll go back to that, Dusty. Thank you. Thank you. It seems like there's a lot of answers and you are all remember your history well. I was gonna give a shout out to our historians that how important it is, regardless of what we study, we need to know our history. Indeed, that is right after, this increase happened right after the Industrial Revolution. I am so grateful for the Industrial Revolution, for the explosion of technology and use of machinery. Therefore, I don't have to worried about growing my own food, making my own clothes, and so on and so forth. However, there might be some consequences that we need to be aware of because of that wide use of resources and also the way we live and the modern amenities and conveniences that is so much part of life today. Now, and yet, I wonder if some of you think that, okay, 2,000 years is pretty long, maybe it is not long enough. So for those of you who are a bit skeptical, I would like to share with you this next set of data that is embedded with previous information that I've shown you, that an international team of scientists put together to study ice core data that dates back 400,000 years. I hope that is long enough. So I hope you can notice in the black lines that indeed there are ice age cycles. That means the carbon dioxide concentration goes up and down. However, if you notice the peak of this ice age cycle would be at around 300, comparing to what we're experiencing today in the 21st century, it is close to 400. And that is a big increase. And another thing I would like to point out that is also concerning to me is if there are really supposed to be cycles that goes up and down, what we are experiencing past the Industrial Revolution is that we are not seeing the amount of carbon dioxide concentration going down. And in fact, we're seeing the trend continue to rise. And that is very concerning. Now, so some put the two and two together. What about the global warming and the temperature rise that we are experiencing? So shown here are two graphs that are put together, which the carbon dioxide concentration in blue zigzag line that you see here, and then the temperature in the red line that you see on actually the y-axis on the right in centigrade. That there's a corresponding trend, there's a parallel in both of them increasing over time. And that strongly suggests that the increase in the carbon dioxide concentration therefore affects the warming of global temperature. But then what about if we pull the timeline back a bit? So here is a graph showing us, again, time on the x-axis and then average temperature on the y-axis, referencing 1901 to 2000. 0 means is average, and when a value is above the 0 line means that that year's temperature is above average. When you see the red bars going below the 0 line, that means that year's temperature is below average. And again, I want to remind us that this is the average global surface temperature. That means it is not just regional, but taking into the Earth in account, into consideration. So a few things I want to explain. Red bars would be the average temperature, and then the black arrow bars would be the range. The blue is a trend line. So you could see that indeed average temperature would go below average up to a point, up to about mid 1900s. And then we are seeing less of a below average surface temperature and more of a above average. And when we get into the later 1900s and 1980s and beyond, we're seeing more red bars above the average, indicating that, and you see that on the corresponding trend line in blue, that indeed the surface temperature has been rising. And again, what is concerning is that there's no signs of it decreasing in any fashion as compared to earlier in history. So I want to show you the next set of charts. So here actually is the global average combined land and ocean temperature. So what I showed earlier was the surface temperature, but now this set of graphs actually combine ocean and land surface temperature. And you can see it on the y-axis is centigrade, And the year, again, is on the x-axis. Now, these are decadal average. That means taking into account 10 years at a time. You've already seen this, but this is just presenting the information in a different way, in which you see that the decadal average differences have been lower than average, but then when we hit the middle of the 20th century, it has been rising. And more so the last 3 decades, the last 30 years, we are seeing successive warmer and warmer temperature. And that is very concerning. And I would ask, after seeing these data, what does that really mean? Well, the 4th National Climate Assessment did a very comprehensive report. And I believe Jennifer will put that link in the chat box and you can further look it up. I recommend it. It's very long. And it talked about many areas here that there are consequences. And by the way, I have intentionally used climate change or referred to the effect as climate change instead of global warming for a couple of reasons. Global warming has some stigma around it, surrounding it, and also it can be very confusing. And secondly, you will soon see that the consequences of climate change is far more than just warming of temperature. You can see here that according to the climate assessment, the report showing us that global annual average temperature has increased by more than 1.2 degrees Fahrenheit from the period 1986 to 2016, and that's just a repeat of what we saw earlier, the decadal average increasing in the last 30 years relative to earlier in the century. And this period is now considered the warmest in the history of modern civilization. This is the image on the bottom right is showing us a surface temperature combining land and ocean. Red means increase of temperature above average, and blue indicates below average. And I think this is pretty clear that the average over time is in red. That means is increasing or being above average. Now, I mentioned about consequences of climate change more so than just warming of temperature. It includes rising of sea level, with coastal areas being affected, loss of polar cap ice, ocean acidification. We can see that coral reefs and the marine life being affected, loss of biodiversity, and severe calamities such as wildfires, so on and so forth, and flooding and storms. So I want to go into each of them and further discuss this with you. This is a study conducted by NASA over a couple of decades, few decades. You can see that the Arctic polar cap ice here on top started when NASA started the study is this size, and how over the 3 decades or so has decreased or shrunk to the size below. And this one actually kind of hits home. I actually personally visited this national park when I was young. The glacier in this Alberta, Canada National Park was here where the sign is in 1992, but has receded in 20 years' time to where you see in the picture. While we might think that the melting of polar cap ice or ice glaciers might not affect us, but most of the potable water or our water resources actually stored in these glaciers. So experiencing a loss of polar ice will actually affect us in ways that we might not think of.
Louise, we have a couple questions that may pertain to this. So the first question is, does the temperature of ice affect the way that CO2 might be measured compared to the data collected in Hawaii?
Does the temperature of the ice affect the way that? To what I know, because the ice in the ice core and the ice cave have been kept really cold, and as a result, it is frozen and is below 0 degrees, and as a result, it is the amount of CO2 that is being captured in that time frame that is being compared to to the a mountain in Hawaii that was being measured in the 20th century.
And then the second question would be, can you explain the Vostok ice core data again? I don't understand why the black lines looked like they fluctuated significantly.
Okay, so we were to go back to the, okay, there's quite a number of slides, so I'm not gonna go back. So in that graph, we see that the ice age cycles do exist. And remember hundreds of thousands of years ago, that would be more so the natural occurring carbon dioxide concentration versus the other processes that were put in place or introduced after the Industrial Revolution. So that is part of the natural process, as I mentioned earlier in the beginning. However, I wanted us to compare and pay attention to the difference between that those cycles, even the highest, the peak of the cycle, compared to what we're experiencing now and noticing now. And also the trend now in these last 200 years or so since the Industrial Revolution, how the line is not going down, or the amount of carbon dioxide concentration is not going down. So I hope that addresses that. Okay, I'm going to continue, and perhaps we can also wait for the end for questions. So I was mentioning that the loss of polar cap ice could lead to the chronic long duration of droughts that we're experiencing. And as a result, we need to pay attention to that. I mentioned about rising sea levels. This is a group of islands in the Pacific Ocean called the Kiribati. And these are their realities in which the rising sea level over time might lead them to become climate change refugees. And they have to battle with these kind of flooding on a very regular basis. Global average sea level has risen by about 7 to 8 inches since 1900. And with almost half of that rise occurring in or since 1993, which is fairly recent. Again, indicating to us the severity of these consequences. More so, global average sea levels are expected to continue to rise at least several inches in the next 15 years, and by 1 to 4 feet by 2100. So we are not seeing any lessening of this consequence anytime soon. Cities that are low-lying and also on the East Coast would be more affected than others. And it could be coupled and more, it could be worsened as there are storms and flooding in those regions. Next, I want to talk a little bit about ocean acidification. So with the rising of temperature on land, it could also warm up the ocean, as you saw earlier on some of the graphs. Now, not only that, the CO2, the additional amount of carbon dioxide concentration in the atmosphere could also dissolve in the ocean. There's a fine, delicate pH or level of acidity and salinity in the ocean. So with the change of CO2 carbon dioxide concentration in the ocean as well, it could lead to the formation of carbonic acid, which is acidic in nature. And as a result, some shellfish could over time lose its shell because of that. It could be dissolved. So that's one, and affecting marine life and ecosystem in the ocean. But also the warming of the temperature could cause these delicate environments to be disrupted, and therefore bringing a lot of harm. On land, biodiversity could also be affected, and therefore species being threatened. You can see here they are the different species being affected, and it's estimated that about 10 to 690 species per week could face extinction. And of course, you might have heard of droughts, flooding, wildfires, which really hits home for us, and extreme storms could be amplified because of climate change. And shown here are some pictures, and here's Half Dome over a period of time, and the rising of temperature affecting the snow cap, so on and so forth. I put in this question because I already received inquiries on email since the title of the talk went out. What about the wildfires that we're experiencing? Are they related to global climate change? Well, I want to start with some pictures that I've taken over time. So I actually took this picture, 2013 Madre fire. I don't know if anyone remembers this. I took it in Segerstrom after I finished teaching in Segerstrom. So that was 2013. And that was 2014. It was very serious. I remember the Kobe fire. I didn't take this picture. It's from downtown LA of Glendora. And the impact was very fast. But seems like after that, I did not run out of case studies or real life scenarios to point to when I talk about air pollution in class. There's this fire in 2017, the Thomas fire that affected so many in a huge region. And then there's the Paradise, the campfire that completely affected Paradise, the city, the town of Paradise, 2018. But it's not just in California. We are also hearing that in Australia. Just earlier this year, 2020, and of course, it's still fresh on all of our minds as it is still going on. The Bobcat fire and other fires throughout California has now set a record so far, and it's just September. The question I asked in class, and I also want to pose it to you, is so should we now expect the worst wildfire next year or next time, that we will always kind of outdo last year? Well, I want to point out that we were very privileged to have this event that Center for Research and Science hosted last year with Dr. Catherine Hayhoe, a leading climate scientist, and theologian Stephen Baumer-Prediger, and our own alumna, Annie McCauley. So I want to encourage you to check it out on our website. But Dr. Hayhoe also spoke in chapel. And Dr. Hayhoe, when asked about wildfires, she said this. She said, we're taking a risk with climate change. It is like throwing dice, and California is getting double sixes all the time. To her, climate change is a threat multiplier, that it underlies certain conditions, pre-existing conditions, to make it even more possible, and as a result, the worsened fires and other storms that we experience. Now, I want to show you this graph with the amount of wildfires without climate change in the yellow, and the wildfires that are represented in the orange. So you can see here that there are more, the area is larger on this graph of wildfires with climate change. I actually read up about this, and I want to share with you this next set of graphs from a PBS article. And I think Jennifer can put that article in the chat as well. So it's true, 95% of the wildfires that we're experiencing in California are caused by humans. And the number of acres burned annually in California wildfire has increased, and this year really set the record. And the causes of the 20 most destructive California fires are caused by these different factors. And from what I've read so far, that there are really three factors into addressing why so many wildfires and why so severe over the years. Well, first, it could be climate change. There's strong correlation with the pre-existing condition of drought that makes the trees and the bushes be very, very susceptible to wildfires, widespread wildfires. Second, it could be mismanagement in forestry, that there were the lack of controlled burning and therefore lead to these wildfires. And thirdly, it could just be increase in population. So I looked up world population growth. And you can see here that in different era throughout history, the world population has been significantly and substantially growing. I've shown you this graph before in terms of the amount of carbon dioxide concentration over time. I think it can, we can see that there's an upward trend almost corresponding to both of them. So I'm wondering if it's just because, or largely because of there are just more people and there's more demand. All of us need to charge our phones, we need to eat, we need to be housed nowadays compared to many years ago. And as a result, I think I would like to ask us, so how do we sustain the way we live as we go forward? As we know that there will be continual growth in human population. This is another chart showing us the growth in global population since the 1800s. And that leads me to asking, after hearing about the consequences, knowing about the effects, and as such, what does this really mean for us? Well, I can tell you, it's going to cost us a lot of money. According to this paper, published on Science, there's a cost of about 1.2% GDP per 1 degree centigrade increase on average. That means if our GDP is $18.57 trillion, and that was 2016, the amount that is going to cost us in climate change related damages would be 220 billion. Now that is only if it's only 1 degree increase on average. What if the warming is exceeding 1 degree on average? Then that means the amount that's going to cost us in climate change related damages would be even more. Second thing that it means for us is that we have big feet. Did you know that? The ecological footprint of the US is reported to be at 6.8. Now we are a developed country, so I want to ask if we were to compare to another developed country, say like France, where do you think France is? Where do you think in comparison? Do you think it's larger, smaller, about the same? Feel free to unmute yourself if you feel comfortable, or you could type it in the chat box. Okay, one of you said same. Anyone else? Okay. Okay, well, it's true. France is a smaller country, so their footprint is actually smaller, 4.2. What about our neighbor, Mexico? What do you think? Would it be smaller, larger, or the same? You are right, it's smaller. Okay, what about China? What do you think is the footprint for China? I see the comment about per capita. I will get to that in just a bit. It's actually 2.5. Granted, the data is a little bit dated, but I want to point out in that same year, the global average was 2.7. So US can safely be 2.5 times above the global average. What does that mean? Apart from we have big feet. I think by the same token, as a global leader, that we can affect change should we collectively want to do so, that we can implement changes and make a difference in these consequences. And turns out I'm not the only one who thinks that. Pope Francis, in his visit to the US, gave a speech in 2015 based on his encyclical Laudato Si. I highly recommend you to read it if you haven't. He actually encouraged the US in several areas that we can be leaders, and I'm especially highlighting stewardship. That he believes, and I agree, that we can take a lead in stewardship and the way that we live and in the days ahead especially. And he's not alone. I wonder if anyone knows who this person is. You could put it in the chat box, or you can unmute yourself. Does anyone know who this is? It's kind of quiet. Okay, that's a good guess. This is the late John Stott, a leading evangelical in Britain. In his last book, his parting words with the church, he urged the church to focus and pay attention to 9 neglected areas of our calling. He calls us to go back to radical discipleship, not in the sense that it's to be more extreme, but like Radish, sharing the same root word, to go back to our roots. And these are the 9 areas right in the center of it. That's creation care. Nearly 20 years ago, John Stott urged us, and I quote, "It is against the background of this wholesome biblical teaching that we need now to confront the current ecological crisis." However, there has been studies indicating that Judeo-Christian traditions seem to be less inclined towards environmental protection and issues than other non-religious peers. I want to pause and ask, why do you think that is happening? Anyone?
Could it be the implications or the association with how the Earth is going to end?
There's theological implications, and also this topic has been so heavily politicized. And we said in the beginning, we're not going to go into that, but I want to encourage us, I want to ask us to think about that. The issue being politicized and therefore maybe polarizing us to come together to find some meaningful ways to go forward. So what can we do in this space, in this time? Well, there are quite a few things. I've shown you a lot of graphs, so bear with me for those who are not used to seeing that many graphs. This is the last set. So according to the Intergovernmental Party of Climate Change, Panel of Climate Change, on the latest report, it shows that the carbon dioxide equivalent predicted in different pathways, the way how we're going to use our technology and our resources from now till the next century could be in different predictions or expressions. And corresponding on the right, you see the temperature change. And the wide spread of shading shows us that there's a range, okay? What I want us to focus on is not just the red line, because that just means that we don't do anything. That's where we're going to head up. We're going to head up towards 1200 ppm. But I think I find hopeful in looking at this prediction is that there are different pathways. That means we can change the future in which we can make decisions that can change whether or not we're going to go above where we are, right around 400 ppm, to holding it steady and not seeing an increase. Now, this 0 line on the right, I want to point out, is the pre-industrial revolution standard or value, okay? And that's what it is. So the first thing I want to recommend, if you've never done this, is to take a inventory of your carbon footprints. And I think Jennifer can put in the link. You can calculate how much carbon footprint, where you live, how many people, and how you use different appliances, whatnot, and to get an idea, what are we talking about? How much are we talking about? Next, there are different organizations that you can be a part of, whether through joining their, subscribing to the newsletter, or even their different activities and events. Young Evangelical for Climate Change is a great way for our students to be involved. And then an international organization that's really centered in, Christ-centered is Arosha. They are a conservation nonprofit organization with different chapters around the world. Locally, we have Eden Reforestation Projects, which is actually founded by one of our alumnus. And I am very proud to share with you Canyon City Environmental Project, CCEP, which is a yet-to-be nonprofit. And it was birthed from my class a few years ago. We have joined forces with the Azusa Mayor, former Azusa Mayor, to do cleanup days in the Azusa Canyon. Perhaps you're not quite ready to take action. Well, perhaps you can stay informed by subscribing to newsletters such as Blessed Tomorrow. And more so, I think Jennifer is going to put the link in that the Jamaica call to action, if we were in person, I would have provided you each a copy of it. I really recommend everyone to read through this call to action and maybe share it with your friends in church and others who can learn from this. It lists this call to action, this document lists quite specific and practical steps that we can take as Christians. And of course, on a personal level, we could choose different modes of transportation. Riding a bike could be a good alternative, but that might not be an option for some. Maybe even walking and other means of transportation to reduce our carbon footprint. Maybe choosing different appliances to substitute and replace them with those that are more energy efficient. According to the Environmental Protection Agency, source reduction is actually most preferred as opposed to recycling or burning and landfilling when it comes to items, commodities, and plastic. And you'll hear more about that from Dr. Richard next time in the next lecture. So my encouragement is consider consumption of items and reuse or repurpose them as we go along. And I don't know if you've ever benefited from the California climate change. I know I have. And it is really a good example of how scientists working together with politicians and the other way around as well. And as a result, you see my bill here from SoCal Gas that I got this California climate credit so that I have an incentive to invest in more environmentally friendly, energy efficient items. And as a result, we can really collectively make a difference to curb carbon emission. Now, in a corporate level, there's other mitigation, such as the carbon dioxide sequestration, in which these steps are being built in to kind of channel carbon dioxide emission away from its source. And as well as in the business model, there's a cap and trade system that LA County actually has in place, that instead of a mandatory reduction, that different factories or industries can actually trade when they don't use to the level, and that they can maybe trade with another factory or industry who use above the level, so that they can all overall maintain the amount of carbon dioxide emission and curb it as low as possible. So these are some creative ways that we are beginning to see, and they can be effective. Again, back to these two graphs I showed you earlier, even though it sounds like all the consequences could be very severe and serious, I do think that the choices we make today can determine what the magnitude is of climate change and therefore the warming of temperature in the next years to come. The earth is the Lord's and everything in it, the world and those who live in it, is a verse that I refer to all the time. Because to me, it is not just something, but everything in the Lord's creation that he expresses himself and he loves, and so should I. Taking care of the earth takes all of us because this is our only home. I think about those who are in the areas such as Kiribati, in which they face the consequences of climate change, in which they themselves did not quite contribute to global carbon emission. And yet, they have to bear the brunt of it. Is that fair? And what action of mine or inaction that lead to their reality? So I want to invite us to consider the earth is the Lord's and everything in it, the world and all who live in it, and also the two greatest commandments, which is what I go back to again and again. How do I love the Lord my God with all my heart, soul, mind, and strength, and loving my neighbor as myself? Who are my neighbors? Who am I called to care for? Is it just those who are living right next to me, or those who may be marginalized, who might be vulnerable? So the title of my talk is climate change caused by humans? I'm gonna let you answer that on your own, because I think that might be an even more important question to ask. What does this mean for you? After knowing this, after hearing about this, what does this mean to you? And moreover, how do we bring shalom to all, not just some on earth as we go forward? And I want to end with an image. I want to leave you with an image. A group of people were traveling in a boat. One of them took a drill and began to drill a hole beneath himself. His companion said to him, "Why are you doing this?" Replied the man, "What concern is it of yours? Am I not drilling under my own place?" They said to him, "But you will flood the boat for us all. We are in this together. No one's left behind." I want to leave you with some reading material in case if you want to further learn more. And with that, I want to thank you for your kind attention, sharing your precious lunch hour with us, and remind you that there are a few more lectures coming, and I hope you can join us as well. And with that, I would like to take any questions and have a discussion with the time remaining as you like. So thank you again.